Okay, hello everyone. Welcome to the service learning project for the course of Communication Principle SEEE 3533. So this is the video presented by Group 14 and we are from section 11 and 12. So here's our team. My name is Chow and my member is Lim, Aina and Assam. So before I start, I would like to thank you everyone of you for filling up the response. I hope that you can really learn something from this video. So let's proceed. So for this course, we are calling it as a communication principle. It's the course that we are using the communication system. So with the communication system, that's why we can use the telecommunication for us to call our friend or family, or we are using the communication system for the broadcasting to hear the FM from the station as well. So what is communication system? It's the process of sending the information signal from one point to another. And this process, we are involving the transmission, receiving, and processing. But in this video, we are mainly focusing on the transmission. So what is the data transmission? It's the process of sending the signal, which is in the digital form or another form, from one point to another. So in order to transmit the data to a far place, we usually involve a technique which is called the modulation. So this is the flowchart for the communication system. So we got the transmitter and receiver. So we are using the modulator to modulate and demodulate to get back the information signal. So in this video, we are mainly focusing on three types of modulation, which is amplitude modulation, angle modulation, and digital modulation. So for the first type is the amplitude modulation, which is AM. So it's the technique of changing the amplitude of the carrier signal. This is the carrier signal and this is the message signal. So we used to combine them together to get the modulator signal to send to a far place. So there are a few advantages because amplitude modulation is more simple design and we can get a lower cost for it. But the disadvantages for this is we can get the more noise for the signal we receive. So this is the AM. So the second one is the FM frequency modulation. Is a little bit different from the AM. It's the technique of changing the frequency of the carrier signal and combine them to the modulator signal. So with this FM, we are usually using this FM mainly for broadcasting. So it has the improved signal quality because it is having a less noise interference. But the advantages for it is it has more complex to design. So the third one is the digital modulation, where it's the technique of we're using the encoding digital signal combining into a carrier signal for a transmission. So there are usually three types of the digital modulation, which is the ASK, FSK, and TSK, and we will discuss it in the video further. So for the advantages for this digital modulation is obvious because it's the best quality of the signal we can receive because it has the minimum noise interference for it. But for the disadvantages for this is we need to do the synchronization for the both emitter and receiver. So this is the digital modulation. So that's all for my part.
Hi, I'm Aina Noha. Now, I will explain about bitrate, baud rate, and baud frequency. Both bitrate and baud rate are generally used in data communication to measure the speed of data. Bitrate is the transmission of a number of bits per second in the unit of we are commonly heard such as kbps, mbps, gbps. It measures how fast the data travels from one point to another. Higher bitrate allows for faster transmission of information, so it is calculated by multiplying the number of bits transmitted in each unit of time. So bitrate is crucial in digital communication networking and data transfer. It determines the audio, video, and internet connection speed quality. When it comes to computer efficiency, the bitrate is more essential since we want to know how long each piece of information takes to process. However, when we are more concerned with how data is moved from one location to another, we emphasize the baud rate more. So let us look at the baud rate now. The number of times a signal can change on a transmission line per second is referred as the baud rate. Each symbol represents data. In some cases, multiple bits can be encoded within a single symbol. So, unlike bitrate, which directly measures the number of bits transmitted per second, baud rate measures the number of signals changed per second. Also, it can determine the amount of bandwidth necessary to send the signal, while bitrate cannot determine bandwidth. Now we proceed with baud efficiency. Baud efficiency is about increasing the bit rate per baud. Methods and techniques are used to increase the amount of data that can be transmitted within a specific time frame by packing more bits into a single symbol or baud. Some of the most common encoding techniques used to increase baud efficiency include ASK, FSK, and PSK. We will go deeper into these methods that will be explained in the next part.
Hello, my name is Muhammad Aslam bin Osman. Now we're going to discuss in detail about the digital modulation. There are three types of digital modulation, which is amplitude shift keying, frequency shift keying, and phase shift keying. So let's go to the first part, which is the amplitude shift keying, also known as on-off keying, is a digital signal modulation where the digital signal will modulate our carrier signal and will produce ASK output signal, as you can see in the graphic here. The string of pulse from digital signal will change the amplitude of the carrier signal. So the advantage of the amplitude shift keying is bandwidth efficiency, and as the disadvantage is more noise, or this type of modulation is more susceptible to noise. So we're going to the second one, which is the frequency shift keying. The idea of generating frequency shift keying signal is by generating two amplitude shift keying signals and adding them together with summing amplifier. This will produce a continuous modulated signal as shown in the figure. In this case, the high frequency will represent as signal 1 and lower signal frequency represent as signal 0. So the advantage of the frequency shift keying is less noise or high immunity towards noise, and the disadvantage of the frequency shift keying is large bandwidth. And you can see here, the SK signal are added out to form a continuous FSK signal, as you can see here. So now we're going to phase shift keying. So this phase shift keying is the sinusoidal output wave will be shifted 180 degree every time the digital signal toggle between 1 and 0, as you can see here. Every time the digital signal toggle between 1 and 0, the shift the the sinusoidal wave will be shifted 180 degree. So this phase correspond to the binary 0 and 1 respectively. So the advantage of the phase shift keying is less noise. Now we're going into quadrature amplitude modulation. The quadrature amplitude modulation is a digital modulation scheme that combines both amplitude modulation and phase modulation. Two carriers are 90 degrees out of phase, which with each other quadrature carriers are used to transmit digital data or over a communication signal, enables the encoding of the multiple bits information per symbol. So the advantage of the QAM is a high data rate by representing multiple bits with each symbol. Bandwidth efficiency, meaning that more amount of data can be transmitted. Robustness to fading, which means that it has a higher immunity towards noise. Compatibility with multiple channels, allowing multi-channel communication. And versatility across transmission media that can be applied in various transmission media such as fiber optic and so on.
Hi, I'm Lim Kai Chong, and I will be continuing the presentation. So basically, there must be a misconception towards the AM, FM, PM, and radio digital modulation when people newly get known to it. So one common misconception about AM is people think that it is the most efficient modulation technique. But in reality, AM is less bandwidth efficient compared to other modulation techniques like FM and radio digital modulation. It can be easily influenced by noise and interference. For FM and PM, people always think that both of them are different, but actually both of them are sharing similarities. The main difference between them are only in mathematical expression. For radio digital modulation, people think that it is error-free, which is no error, but in reality, although radio digital modulation provides better noise resilience compared to analog modulation, but it is not completely error-free. It still can be affected by channel noise and system limitation. Next, I will be introduce the technology that apply those communication principle. Technology that applying AM is shortwave radio, where it can perform a long distance communication. For FM is commonly used in radio broadcasting for its high fidelity audio transmission because it provides a better signal quality and have resistance to amplitude noise. For digital modulation, it widely used in cellular networks for transmitting data efficiently. Technology like 3G, 4G, and 5G use advanced digital modulation schemes to achieve high data rates. Next, I will talk about the benefits and impact of the technology towards the society. So for AM radio, it has the ability to cover long distance without relying on complex infrastructure, make it valuable for emergency broadcasting, for example, during natural disaster or emergencies. AM radio also can provide crucial information to a broad audience. For a FM radio, because of its high fidelity audio transmission, it is widely used for music, news, and entertainment. it contributing to cultural and societal connectivity. Lastly, for digital modulation in cellular networks, it significantly increased data transfer rates, allowing for faster internet speeds, multimedia streaming, and advanced applications. In conclusion, we have explored fundamental communication principles in this video. This technology is crucial in modern communication systems. It ensures the efficient and reliable transmission of data. So understanding these principles is vital in navigating the world of communication technologies, whether it's the traditional analog methods like AM and FM or the cutting-edge digital modulation techniques. These concepts forms the foundation of effective communication in our future advanced world. That's all from us. Thank you.